All right, a 15-minute summary of Year 8 Algebra. We can do it. First of all, to start off, we need to acquaintance ourselves with the language of algebra. So these are different words you might see in worded questions, and you need to know what it means. So if you see something about sum, it is about adding. Something about difference, you're looking at subtraction. Quotient is to do with division, and the product is timesing. You can think of some cool ways to remember these, but I kind of think of like the sum of two things is like the adding of two things. Difference is minus, that's like really easy to remember. Quotient though is like the fancy one, and I like to think of division as like the fancy thing, but you know, that's just me. Anyway, we got no time to waste, we must keep moving. Double means 2 times something. So 2 times something. And what we have to look at is what's the difference between an expression and an equation. An expression has no equal sign. So something like what is down here, 3x plus 5, while an equation has an equal sign. Those are the two differences. I'll do a whole video on equations later, but for now we're looking at expressions. And language of expressions, the letters in these, they stand for any number in the whole wide world. And this is what we call the pronumeral. So the fancy letter is the pronumeral. The number before it is the coefficient. Most probably did that. And this is a constant term. So if you see a number by itself, it's 5, it's a constant term. Whilst anything else with the coefficient and a pronumeral, that's just labeled a term. We call the number a constant term because the 5 will always be 5, no matter what the expression is. But every x you put in here, be it 1, be it 2, that will change the term. So it's not constant, it's a changing term. So we want to have a particular look as well at like terms. So let's look at our 3x here. 3x, if we were to expand it out, is the same as 3 times x. There's one letter and one number. So if I was to say, ooh, 5x, is that a like term to 3x? Well, let's expand it out. Is that, oh, sorry. It's 5 times x. Do we have a letter? Yes. And do we have a number? Yes. These are like terms. But if I was to bring this little bub to the mix for xy, 4 times x times y, ooh, that is not a like term. Can you see how there's a y there? Or maybe 4x squared, which is the same as 4 times x times x. Ooh, we got 2 x's. No good. So when we want like terms, they are identical expanded form in terms of letters. So we can add and subtract like terms. Let's go down and get some space here. So we can add and subtract like terms. So let's identify the like terms here. I suggest, boxing up your like terms so you know what's what. So 3 times x is a like term to 4 times x. You add them together and you've got 7 of them. 5, constant term, but it's got no buddies, so it's by itself. And this, which is 7 times x, it's not a like term, remember, it's got 2 x's. So that's going to stay plain by itself. And we're not going to add any of these together. So here's another example here. Let's first look for our like terms. So we've got a minus 6a, which has got 1a. Anything else with 1a here? Yeah, minus 12a. Fun. And let's look here. We've got a plus 4a squared. Oh, ooh, this one here has a squared. And the little constant terms by itself. So we've got minus 6a minus 12a. Plus 4a squared. So you bring the sign before the term along with minus 3. Let's focus on this first. Minus 6 minus 12. So it's something in the negatives and we're going further down. So that's going to be minus 18a. And that's pretty clear. That's 13a squared for the next one, minus 3. Done. We do not do anything further from there because we can only add and subtract like terms. On the other hand, you don't need like terms to multiply and divide terms. Everything just happy. It can all be together. So let's try this one here. We've got 4x times 5. So you can actually put this together. 4 times 5 times x, and that's 20x. Boom! And remember, when you've got a division, that's just a fraction problem in disguise. So you can actually make it like that. So adding and subtracting, you need like terms, but multiplying and dividing, you can just multiply and divide any terms together. We then came to a part of algebra where we had to expand and factorize. So expand is when you've got a bracket and you have to bring whatever is in front of the back bracket and times it by what's in the bracket and transfer the sign. So let's do that first. We've got a plus in the middle. So over here, we've got 5 times x. 5 times x is 5x. And the next one here is 5 times 1. 5 times 1 is 5. Let's see if I can give you a trickier one. Let's try this. So you can pause and give this a try and see what you get. All right, welcome back. So we're going to times this here. 7 times k, which is 7k, transfer the sign, and then 7 times 3a. 7 times 3 is 21, and a. Done. It expanded. That's the easy one. Factorizing is when you've already got the expanded form. So you need to find a common factor, the highest common factor between these, put it outside the bracket, and imagine what would be inside the bracket to make this work. So a way I recommend to do this is to write each of the terms out like this. Now let's look at the number first. What's the highest common factor between the numbers? Well, you could use a 4, so we're going to take a 4 out. All right, so we know that the 4 is out, and let's look at the letters. So let's look at the m's first. The highest common the best factor we can take out of it is 1m out of each. So actually, this isn't just a 4. You can actually make it 4m because there's an m in both those terms. Now let's look at the n. And there's one n in each of them. Ooh! So we can put an n here. All right. So now, 4mn, what do we have to times by to get to this? Well, that'll just be 1. Bring the sign in. And what do you have to times 4mn to get to this? We'd need a 2. So the 4 would get to 8. And then we need an extra m. Done. We have factorized. Let's do another one. Not as scary, hopefully. So let's put this out. 12 times x plus 6. All right, focus on the numbers first. What number goes into both of these? That would be a 6. Then we look at our x. Anything on the other side? Nope, nope. So we're going to keep it 6. 6 times what would get to here? 2x. Because the 2's for the 12 and the x for the x. What do you need to times 6 by to get to that? Just 1. Done. We have factorized that one. Now the next part is about index laws, but let's not make it too hard for ourselves. I'll just write out what I'm trying to say. You don't have to remember this is index law 1, index law 2. Just have to remember these following rules. So if you see a times a, that's a squared. Because it's a number, whatever the number is, squared. If you see like a to the power of 3 over a to the 2, it's really easy. Expand it out. And then see what you can cross out. A crosses out of this, A crosses out of this, and you're left with an A. This is pretty much all you need to know in disguise. You might see an a squared to the power of 3. It's just about writing it out. So this is the same as a squared times a squared times a squared. Then write that out if you need. A times A times A times A times A times A. How many A's are there? 6. In other words, you can times outside the bracket. And the last one is if you have a to the power of 0, that is going to equal 1. So let's put this into practice. These are those classic simplify questions. So you've got this to simplify expression. So let's actually write it out. 5 times x times y times 2 times x times y. Alright, so let's do the numbers first. Minus 5 times 2, negative times positive is a negative. And then let's look, we've got 1, 2, 3 x's. That's x to the power of 3. And we've got 2 y's, so that's y squared. Let's try another one. It's a division problem this time, and it looks like Kit Kat. So let's expand it out. 16 times k times a times t over 12 times k times t. Cross out the letters on the top and the bottom. Bye-bye k, bye-bye k. Bye-bye t, bye-bye t. And see if you can do anything with the numbers. Ooh, you can divide both of these by 4. So we have got 4ka over 3 over 3. Done. The last little area of algebra was about substitution. So you might see a question saying evaluate or substitute. That means that we put whatever they tell us to, so A is going to be 3 and B is going to be 4, into our expression. So wherever you see an A, you have to follow the rules. So let's expand everything out first. What is it asking us to do? 7 times A divided by 4 plus B times B. So this is 7 times 3 over 4 plus 4 times 4. Alright, let's do it bit by bit. Let's focus on the fraction. So this is 21 over 4 plus, and remember BIDMAS, you're going to do your multiplication first. Whatever the answer is to that, I should have thought of something better, is your final answer. So my recommendation for these substitution questions, even if it's something like 6x plus 2, is to write out, and remember this is 6 times x plus 2. So if x is equal to 1, this would be 6 times 1 plus 2. And BIDMAS, 6 plus 2 equals 8. So hopefully that's a good summary of algebra and what we did. So remember the language of algebra, difference between like terms and not like terms. You can add and subtract like terms only. So you can't add and subtract anything. It has to be like terms, but you can multiply and divide anything. We did some expanding, factorizing, and some simplifying and substitution. So hopefully that gives you a good idea of algebra. Make sure to do some practice, and we'll see you in the next video.